So let us start concept of increasing and decreasing function. What is an increasing function? Let us proceed graphically first. For an increasing function, the value of x goes on increasing. Value of y also goes on increasing. So, if we draw the graph of a function like this, it's an increasing function. Y, x. If you take any 2 points here, x1 and x2, then for x2 greater than x1, a function y equal to fx is increasing on an interval I if for x2 greater than x1 fx2 greater than fx1. I told you this is the graph of increasing function. By this definition, at every point this is not valid. If we take 2 points here, 2 points here, that is say x3 and this one x4, for x4 greater than x3 greater than equal to x3, fx4 going to be equal to fx3. So in the definition of increasing function, this concept also has to be introduced, where for x2 greater than x1, fx2 may be greater than or equal to fx1. Okay, this is for increasing function. But this is just increasing function. This is not a strictly increasing function. The case I have written over there in the beginning, that is the case of strictly increasing function. This is the case of strictly increasing function, and this is just increasing function. So basically increasing concept arises if this is true, but definition wise this one also to be considered, although it is constant in between 2 points. Okay, unless otherwise stated, we will go by this definition of increasing function. That is, for x2 greater than x1, fx2 will be greater than fx1. So this class will be doing what is expected from you in your board examination. You do graphically or analytically, this definition you need to keep in your mind always. Okay, so let us do one example. Let us solve one example for the function fx equal to, say I am writing 3x plus 8, where x belongs to R. Check whether this function is increasing or not. We have to check whether it is increasing or not. So we'll answer this manner. We'll let x1, x2 belongs to R and x2 greater than x1. This implies 3x2 greater than 3x1. This implies 3x2 plus 8 is greater than 3x1 plus 8. Or this implies fx2 greater than fx1. Clear? So this function is increasing. From graph also it is quite obvious that the function going to be an increasing function, because the graph will be like this: fx equal to 3x plus 8. You know, it is a graph of straight line only. Okay? So this function is increasing. Let us take another example here, that fx equal to, say I am taking second example, that fx equal to 2x minus 3 divided by 4x plus 5 for x greater than 0. We will go by the first definition only. What is that? We will assume that x1, x2 belongs to R greater than R plus, because it is greater than 0. So x1, x2 belongs to R and x2 greater than x1. Now from this one, proving like the previous sum may be a bit difficult. So what I am doing there, we are required to prove fx2 greater than fx1 or fx2 minus fx1 greater than 0. We are supposed to prove this. For this proving, we are taking from here, let us take fx2 minus fx1 here. This will be 2x2 minus 3 by 4x2 plus 5 4x1 plus 5. Okay. So if you take the LCM, x1, x2 both are positive, because if you say that x1, x2 belong to R plus, this indicates that both are positive quantities. So multiply 8x1, x2 plus 10x2 minus 15 minus 8x1, x2 minus 12x2, then 10x1 minus 15. Clear? Let us simplify it. These two are getting cancelled. Minus 15 plus 15 also, and we get 10 into x2 minus x1 plus 12 x2 minus x1 by 4x1 plus 5 into 4x2 plus 5. Okay, this you can write 22 into x2 minus x1 by 4x1 plus 5 as x2 greater than x1. This implies 22 x2 minus x1 greater than 0. Also this denominator, this product also greater than 0. Also 4x1 plus 5 greater than 0. 4x2 plus 5 is also greater than 0. Therefore, the result you got here, this one, fx2 minus fx1 is 22 into x2 minus x1 by 4x1 plus 5, 4x2 plus 5, this is greater than 0. Clear? So this implies that fx2 is greater than fx1. It means the function is increasing over there. Clear? Now we are going to state the monotonicity. One more thing, that increasing function concept only done, decreasing function is what? Let me explain that graphically and with the definition. Decreasing functions. From graph, if you draw the graph of a function like this one is a decreasing function, graph of decreasing function. Okay, because here x2 is greater than x1, x2 greater than x1, and fx2 less than fx1. Okay, maybe like this also, like previous case. This is the case of strictly decreasing function. This is strictly decreasing function. We can take a graph this manner also. This is also a strictly decreasing function. You must have seen in many cases where y proportional to 1 by x or 1 by x square, it is the graph of decreasing function. Value of y gradually decreases. Maybe curve or straight line, it doesn't matter. But all these are cases for strictly decreasing function. This you can refer as strictly decreasing function. Okay? But function may be only decreasing also. What way? That's why graphical approach is important. You will always be able to see that why this one is just a decreasing function, not strictly decreasing. Because if I take points here and here, this is x2, this is x1. So this is valid. For x2 greater than x1, fx2 is greater than fx1. But if we take 2 points on this where graph is parallel to x-axis, x3 and x4, here it is not true. Here for x4 greater than x3, fx4 is equal to fx3. It also can arise. So in the definition of decreasing function, we have to define that a function y equal to fx is decreasing on I if for x2 greater than x1, fx2 less than equal to fx1 occur. Okay, fx2 may be equal to also, there also we have to say decreasing, but we will prefer to know strictly decreasing function. Both people want this strictly decreasing function. Please remember this. When you are going for board examination, strictly decreasing function or strictly increasing function will be more important. Now you take a function, say fx equal to one by x plus 2 for x greater than 0, or I am writing another one for you. Fx equal to 3 by x square for, show that these functions are decreasing. Another thing you have to keep in your mind, function increasing, function decreasing, they are together called monotone functions. Monotone functions means what? They are either monotonic increasing or monotonically decreasing. Okay? Mi or md together implies monotone function. Now for x greater than 0, to prove this, how to proceed? Fx equal to 1 by x plus 2. You can start the same manner, that is, let, answering this way, let x2 greater than x1. So 1 by x2 should be less than 1 by x1. Or you can write another thing, this implies x2 plus 2 greater than, you agree? So if you take the reciprocal, it's happening this way. But this is what? Fx2 and this is Fx1. So for x2 greater than x1 implies Fx2 less than Fx1. Hence the function is monotonically decreasing. You try next one. Fx equal to 3 by x square. Try once. Fx equal to 3 by x square. Try. Check whether it is monotonically increasing or decreasing. Fx equal to 3 by x square. Same manner. 3 by x square is the second problem. For x greater than 0, so that it is monotonically decreasing. How to? I'm just changing the board here once, okay? So you are doing it for Fx equal to 1 by x square for x greater than 0. You can state this manner, for x2 greater than x1 Fx2 minus fx1 equal to 1 by x2 square minus 1 by x1 square. Take LCM. So this is becoming x1 plus x2 this you all know. For x1 greater than x2 this is positive, x1 minus x2 negative, this one positive, so this has to be less than 0. As x2 greater than x1, what does it imply? This implies fx2 less than fx1. So the function is, therefore fx is MD function. So fx is monotonically decreasing function. Clear? Done? Now, increasing or decreasing at a point also you need to define. Okay? Whether a function will be monotonically increasing or decreasing at a point. Let me discuss one by one. So, increasing or decreasing functions at a point. What do you mean at a point? Interval was okay, perfectly alright. Why at a point? Because we will basically observe the tendency of the graph of the function. Whether the graph of the function increasing or decreasing. But at a point when we specify, we need to draw the neighborhood of the point. Okay? Suppose this is the graph of function. We want to check at this point it is increasing or decreasing. Point is A or A comma 0, whatever you say. I am not writing A comma 0. And its neighborhood. Neighborhood means it's an open interval in the surrounding of the point A. This part is A plus H, A minus H. So if you write NBD of A, this is nothing but A minus H, comma A plus H. This is called neighborhood of the point A. So the function is increasing. We observe that it is increasing function. Function y equal to fx is increasing at A. A function y equal to fx is increasing at x equal to A if it is increasing at x equal to A if f of A plus H is greater than fa is greater than fa minus H. There is no contradiction. Okay? It was over the whole interval. Now it is at a point, because this kind of situation arises when a function going to be one part mi, I mean monotonically increasing, the other part going to be md. Those kind of functions are not monotone functions over the whole interval. I am coming back to that point. Just you try to understand this theoretical concept. Function y equal to fx is increasing at x equal to A if f of A minus H is this portion, fa is this portion, this is f of A plus H. If this thing less than this, then it will be monotonically increasing. What will happen for decreasing function at a point? Again the same manner. We proceed for an MD function, monotonically decreasing function, it is decreasing. The graph of the function is decreasing. It decreases, but we want to define MD function at a particular point, say at x equal to b. So again you consider the neighborhood. It is b plus h and this part is b minus h. So let us start our definition. Function is MD at x equal to b if a function y equal to fx is MD at if f of b plus h less than fb less than fb minus h. You can change this approach. F of b minus h greater than fb greater than fb plus h. Same thing. The function is monotonically decreasing. Now, why have I told you these two things? Before we start, the actual formula for finding whether increasing or decreasing, but basic definition is there. For x2 greater than x1, fx2 should be greater than fx1, isn't it? For MD it is opposite. For x2 greater than x1, fx2 should be less than fx1, isn't it? Now if we go through the graph of the function, I have used different words, sorry. If we use the graph of function, say here, when it is monotonically increasing, for monotonically increasing, if we draw tangent to the curve at the point, then dy by dx at this point should be 0. This point is a comma fa. So a function is mi on I if dashed x greater than 0 for all x belongs to I. Derivative should be greater than 0. Then you will tell me why this concept? Because this concept will help us to observe more accurately at a point why this is decreasing function. At that particular point you draw the tangent for decreasing function. Sorry. What do you observe? It makes obtuse angle at this point. So in an interval made of these points only, every point we check whether it is increasing or decreasing. Over the whole interval it will be increasing or decreasing. Function is mi on I if f dash x greater than 0 and md on I if for all x belongs to I. Clear? So these are the cases for mi or md functions where derivative plays important role to understand increasing or decreasing. Now we will be going by this definition, that is if dash x greater than 0 for all x belongs to I and if dash x less than 0 for all x belongs to I, it is monotonically decreasing. So let us start with a function where we are going to decide. Another thing is very important. You can write in word a function, it's very important note, a function is either increasing or decreasing in an interval. Okay? But no, it cannot be, it can't be both mi and nd. Whenever this case arises, you will say it is not monotone function. If it happens, it is not monotone function. For example, I am showing you this function. Say I am taking one part of sin x. The graph of sin x from O to this point, or from O to this point, it is not uniformly increasing or decreasing, isn't it? Function is y equal to sin x. This point is pi by 2, pi, and this is 3 pi by 2. Okay, let me draw a bigger diagram. You will understand better. I have just drawn one part. And here also it has portion on left side also. Y, this is x, this is 0, pi, like this will be pi by 2, 3 pi by 2, 5 pi by 2. What is your observation? It is increasing from 0 to pi by 2. It is decreasing from pi by 2 to 3 pi by 2. It is again increasing from 3 pi by 2 to 5 pi by 2. Increasing, decreasing here. So if somebody has asked you y equal to sin x is increasing on 0 to 5 pi by 2, decreasing on 0 to 5 pi by 2, neither increasing nor decreasing between 0 to pi by 2, constant throughout the interval. Your answer will be it is neither increasing nor decreasing. If you restrict the domain, then it is going to be increasing or decreasing, but as a whole, on the interval 0 to 2 pi, it is neither increasing nor decreasing. Clear? So a function together cannot be both increasing and decreasing. Let us take an example where I am going to decide whether function, another thing. If you give your answer in the interval pi by 2 to 3 pi by 2 it is decreasing, 3 pi by 2 to 5 pi by 2 it is increasing, it is perfectly alright. Because you have specified why increasing, why decreasing. When you are stating about pi by 2 to 3 pi by 2, it is not both, it is just one. 3 pi by 2 to 5 by 2, just one, not both. So we will be taking the help of the number line, the wavy curve, or number line, whatever you say, to decide quickly for polynomial functions. Let me do it for a polynomial function first, that is fx equal to 2x cube minus 3x square. The question is find the interval in which this function is increasing or decreasing. Find the interval. Where this thing is number 1 increasing and number 2 decreasing. Let me do in details. So for increasing function, what happens? Fx increasing, I am writing I. fx increasing on I or in I if f dash x greater than 0. This implies 6x square minus 6x minus 12 greater than 0. This is what? 6 into 6x square minus, you take 6h common better, then factorize it. 6x square minus x minus 2 greater than 0. 6 is positive, so you can write x minus 2 x plus 1 greater than 0 for increasing function. For decreasing function, you take the help of advantage of the previous step. For decreasing function, f dash x less than 0. So this implies less than 0, that is x minus 2 into x plus 1 is less than 0. Clear? So decreasing that part, increasing this part, separately done. Now what we'll do there, we'll draw the sign scheme of x minus 2 and x plus 1. It is going to be sign scheme for f dash x. What is the convention? You find the critical points. Quite obvious. It is 2 minus 1. Okay, we will be checking there. So minus 1 here and 2 there. Origin is somewhere like this. Okay, that is 0. Now, okay, we just take the wavy curve concept. You are all familiar with this. Greater than 2 all positive. In between it is negative. Then again positive. Okay, you can decide by putting value also. So the function will be increasing where it is positive. Therefore fx is increasing if x belongs to minus infinity minus 1 union 2 to infinity. Okay, done. And decreasing, it will be decreasing when x greater than minus 1 less than 2. Alright. So this is one polynomial function we have solved in details. Let us go for a trigonometric function to decide where it will be increasing and where it will be decreasing. I am taking the function, say fx equal to cos 4x when x belongs to 0 to pi. I have reduced your work to decide where it will be increasing, where it will be decreasing. If you graph the function, cosine function only will be there. So on the interval 0 to 2 pi, we have to find where it is increasing, where it is decreasing. Graphically, you cannot get all these things. Particular interval you will not, you can get if you plot cos 4x. But the method I am going to tell you, it is quicker than that. Without mistake, you can get it. Okay? And also before I do it, I would like to tell you that the point the points at which derivative vanishes, those points are called critical points. Okay? So we will find critical point. Then we will plot the sign scheme of f dash x, then proceed. So let's start. Here f dash x is minus 4 sine 4x. Okay, equal to 0 implies, so 4x equal to it will be pi, isn't it? It will be 0, pi, 2 pi, 3 pi, 4 pi, like that. So x going to be what? 0, pi by 4, 2 pi by 4, 3 pi by 4. The problem is interval given 0 to 2 pi. Many points we have to consider. Let us consider. I have given the sum. This is pi. Next one will be what? 5 pi by 4. So small. Next one it will be 7 pi. No, after 5 pi, 6 pi also there. No? After 5 pi, 6 pi also there. 6 pi by 4. 6 pi by 4 means what? 3 pi by 2. Now stop. No other critical point will be there. Because next one, if you tell that, I will tell 6 pi. Acha, no, is it exceeding? Check once. 6 pi, if you take 6 pi to took 7 pi, is it exceeding? No. 7 pi by 4, not exceeding. But if you take 8 pi, then exactly equal. The point will be 7 pi by 2 and 4 pi. Clear? No, 2 pi, sorry. It is 2 pi. 7 pi by 4 and 2 pi. Clear? Now we have to plot on the number line all these points. Nothing to do. 0, 2 pi. This is pi by 4. And 7 pi by 4. Your common strategy will be you take the smallest interval of your choice, then decide sign over there and go accordingly. What is ddx? Whose sign scheme we are going to consider? It is sign scheme of f dash x. Okay? 4 sine 4x. Let me take this interval. This is shortest one I look, or this one, as you like. For x greater than pi by 4 less than 2 pi by 4, x will be greater than pi less than 2 pi. And our function is what? F dash x minus 4 sine 4x. So in this interval, sign is negative. This interval sign is negative. So what is sign scheme of minus of that? It will be plus. Am I clear? Before it minus, after it minus, minus, alternate plus minus. Okay? Then again minus, again plus. Hope all of you can write the answer. This is negative where? 0 to pi by 4, 2 pi by 4 to 3 pi by 4, pi to 5 pi by 4, 3 pi by 2, 7 pi by 4. You will get the scope of solving yourselves. So when you are writing your answer, it is increasing when x belongs to where? 0 to pi by 4. What then? Union 3 pi by 4 to pi. Union 7 pi by 2, because they said 0 to 2 pi, you have to do all. Alright? This is increasing. Increasing means where minus of that is positive. Oh my god, 0 to pi by 4. Wait. Here we want sign scheme of this. Then you do it for cos 4x. So this one negative, derivative negative means original function is decreasing. Clear? So 0 to pi by 4 I have written not properly here. What happened in this interval? Pi by 4 to 2 pi by 4, it is negative. So 0 to pi by 4, sin 4x are negative, so it is correct, plus. Before that minus, after that minus, then plus, then minus, then plus, then minus, then plus. It is correct. So it is 0 to pi by 4, no, but not increasing. For increasing it will be what? That the mistake I did definitely. Increasing when I have considered sine of minus sine 4, and that part is done. Derivative sign now I will write. Accordingly I will say the answer. Increasing when? You write the open interval always. Pi by 4 to, in this school otherwise you will not get marks. So it is pi by 4 to what? 2 pi by 4. Then union of those parts where it is positive. 3 pi by 4 to pi, 5 pi by 4 to 3 pi by 2, 7 pi by 4 to 2 pi. It's like that. Increasing here. Just write union of three pi by 2. Clear? Done? And decreasing on the alternate intervals. Let us go for another one which is very challenging and very interesting. Then rest of the sums you can approach. You have to do it for, I am reducing the sum. Sin x minus cos x in what? 0 to pi. Very short. You decide which interval it is increasing, which interval decreasing. Within 0 and pi. You can take close to 1 also, no problem. Sin x minus cos x. 0 to pi. Changing the board once more. So let me start. For sin x minus cos x, we'll find critical points. F dash x is cos x plus sin x for critical points. F dash x should be 0. This implies cos x plus sin x 0. tan x minus 1, x equal to 3 pi by 4. Falls in the interval 0 to pi. That's it. Okay. Now decide where it is positive and where it is negative. How to? That f dash x, what have you got? It is cos x plus sin x. To determine the sign, it is better you express in terms of one sine or one cosine. How to? You multiply and divide by root 2. So it will be cos x by root 2. So this will be what? Root 2 sine x plus pi by 4. You all agree? It is root 2 sine x plus pi by 4. We are going to draw sign scheme of this only. Sign scheme of f dash x. How do you decide the sign quickly? You can plot or you don't plot. You take this interval first. For x greater than 0 less than 3 pi by 4, x plus pi by 4 is greater than pi by 4 less than pi. Okay. So what happens in 0 to 3 pi by 4? In this coordinate, sign is positive. So increasing here and decreasing here. Clear? Done? Now another very interesting question I will discuss with you, then it will be your turn to solve many problems with me. So let us take an example, like, because I have seen many students, not only one, many students do mistake here. You can write the function for checking whether increasing or decreasing. The function I am writing here, fx equal to x minus 1 whole cube. It is inserted sum, inserted type. Maybe exact sum is not there, but this type. Find the interval in which it is number 1 increasing and decreasing. Can you find? You think? Then I will solve. Function is this: x minus 1 whole cube, x minus 2 square. Okay, I help. So we'll start answering this way. F dash x we find. What is it? Isn't it? This is f dash x. We have to factorize it. For that, I am going to take x minus 1 whole square, x minus 2 as factor. Isn't it? So there will be x minus 1 whole square, and this is 5x minus 8. Okay. So how many critical points are there that you can observe? How many critical points for this function? 3. 3 critical points are there. I mean, where derivative vanishes. 8 by 5 larger than 1. The problem that 8 by 5 is larger than 1. 2 is larger than 8 by 5. 1 is there, critical point taken. For algebraic polynomial function, there is an advantage. If you can factorize, the sum is done. On the right side of the highest one, we always put plus. Then we start our evening walk from right hand side. Okay? We observe the point 2 is there. What is 2's index? 1. So change the sign. Then what do you observe? The point 8 by 5. What's the index? 1. So again change the side. For this one, there is no way it will be same because it has even index. Clear? So this function which I have taken here, this function increasing for what value? Fx is increasing when x belongs to minus infinity comma 8 by 5 union 2 to infinity. And decreasing when x belongs to 8 by 5 comma 2. But you know, this answer is incorrect. We have done like previous sum method only. But here we are getting, and here we are getting the interval for which it is increasing for decrease, but answer is wrong. Why? Because I told you, unless otherwise stated, we will be taking strictly increasing function. Am I correct? This I told, not increasing or decreasing, strictly increasing. Just increasing, just decreasing, no, strictly increasing. Here the derivative will vanish at 3 points. Okay? But you can see that fx, the function fx is there. Fx will be vanishing at which point? At x equal to 1 and x equal to 2. So if I mention that point minus infinity to 8 by 5, I am wrong, because 1 is there, why derivative vanishes? Derivative is there, it vanishes. For 2 it is okay. In between 8 by 5 and 2, is there any point? No. So I have to exclude this one from this portion. You said minus infinity 8 by 5, no. It will be this minus 1. Write in the form of set or minus infinity to 1 open bracket union 1 to 8 by 5. Clear? This is very, very important concept for board exam. Normally in a board exam, this kind of questions are asked. Difficult sums also there, we'll solve it. So let